Hello class, this is Mr. Flamingo. Happy Thursday. Hope you have a good class. Uh, I know I'm not there with you guys again for another day. I wish I was. Still stuck in class. Right now I'm in Boston. I had class from 9 a.m. to 8 p.m. Right now it's about midnight, but it's probably 9 o'clock your time. Hopefully you enjoy this video. I want to teach y'all something or another application of the derivative. Before I start, first of all I want to apologize for yesterday. I guess I messed up in the math in your video. Beatrice texted me and then let me know that I messed up really bad. So when we get back, we'll talk about it. I'm going to move on to the next topic, but I just want to apologize that I'm sorry for messing that up for you guys. Even I make mistakes. This is another application of the derivative. It's called linear approximation. Essentially, I could use a tangent line or a derivative to approximate the value of a point at a function. So normally I could just plug in a number. Like if I wanted f of 1, I would plug in 1 into the function. If I wanted f of 10, I'd plug in 10 in the function. But what if, for example, I'm looking down here, f of 1.2? And that's not something that's very easy to do. It's something I don't want to use a calculator for. I mean, you can, but it's something that we don't prefer to do. So how can you do that? There is a definition, and there's actually a, let me just move this up real quick. There's actually a formula I want you to write. The linear approximation, let me put this in black. The linear approximation, f of x is roughly equal to f of x0 plus f prime x0. Sorry, this is really hard with the mouse. Times x minus x0. So at the end of this problem, you're going to get a line formula. Okay, it looks just like point slope. It looks like slope intercept. Here's my intercept. Here's the slope. Here's a point. It looks sort of like slope intercept form, but essentially, if there is a problem that I don't know, I can approximate it by f of x0 plus f prime x0, x minus x0. Where x0 is a number that's really close to x, that's something that I could actually calculate to sort of approximate x. Okay, so really copy this down, copy this formula down. All you're doing is basically working off this formula. Example 1 says find the local linear approximation of 1.2. And then this one says over or underestimate. And this whole part, I'm just going to have you cross out. Alright, so here's my first problem. I get f prime is x squared minus 4x plus 7. It says 1 comma 5 is a point. Alright. So first of all, and maybe I'll type this, I want to know what f of 1.2 is, but I don't want to plug in 1.2 in this problem, and not to mention this is f prime. I don't even have an f of x to plug in 1.2. So how I start up all of these linear approximation problems is write out the formula. I use a half equal sign. F of x is relatively or roughly equal to f of x0 plus f prime of x0. X minus x0, where again x0 is a point very, very close to x. So if my number is 1.2, can you guess what number I should use that's really, really close to 1.2 that I can calculate? Yeah, 1. So let's rewrite this problem. F of x is roughly equal to f of 1 plus f prime of 1, f prime of 1, x minus 1. And now I'm so close to getting an actual equation. Again, your goal to this is to get an equation. F of 1, in my problem, do you see how they give me 1 comma 5? So f of 1 is 5. Or when I plug in x for 1, I get 5. Plus f prime of 1, they don't give me f prime of 1, but they do give me an f prime formula. So if I plug in 1 in x, I get 1 squared minus 4 times 1 plus 7. 1 squared is 1, minus 4 is negative 3. Negative 3 plus 7 is 4. And then x minus 1. And now I have got an equation that is very, very close to 1 that I could solve for an actual value. In this particular problem, I want to know 1.2. I want to estimate it. I want to approximate it. So all I'm going to do is plug in 1.2 where I see x. So f, again, this is what I'm looking for, f of 1.2 is relatively equal to, or closely equal to, 5 plus 4 parentheses 1.2 minus 1. Now, the reason why we're able to do this is because this is close to 1. I can actually calculate this in my head. 1.2 minus 1 Yeah, 0.2. And then you can calculate, I know it might be a pain to do this by hand, but 4 times 0.2 is 0.8. So my answer is 5.8. Hope I did the math right. Yep. That's how you do a linear approximation. So if you're a little bit rusty, so most of the problems will look like that. Here's another example. Use a tangent line at x equals 4 to approximate f 3.9. So my goal is to get f of 3.9. Well, first I need an equation, so let me plug in the formula. Again, they all start with this formula. F of x is roughly equal to f of x0 plus f prime of x0 times x minus x0. Okay, just like the last problem, first I'm going to get an equation of a line. So f of x is equal to, I put in one too many parentheses, but f of x0. So do you see how I don't have an f of x0? So if I want to estimate 3.9, guess what's a number really, really close to 3.9 that I can approximate? Yeah, 4. There's a hint right here. So let's plug in 4 to get f of x0. Or how about this? F of 4, because I'm looking for a number close to 3.9, I want 4. Okay, so far? All right. So now I'll look at this. I get f of 4, which I don't have, but if this is f of x, I can plug in a 4 here. 2 times 4 is 8. 8 plus 1 is 9. Square root of 9 is 3. F prime of 4, they didn't give me. Yeah? But they did give me f of x, so I could figure out what f prime x is. Can you guess what rule I'm going to use to take the derivative of this? Yeah, chain rule. So I can't take the derivative of this, so I'm going to rewrite it so it's something I can take the derivative of. 1 plus 2x to the half power. Okay, so far. And using chain rule, I'll move the half out in front, leave the inside alone, to the negative half power, so I'm subtracting 1. And I multiply by the derivative of the inside, which is 2. You'll notice that half and 2 cancel, so the whole derivative is going to be 1 plus 2x to the negative half power. So this part right here, and some of you may not know what this means, so I'm just going to simplify this. This is the exact same thing as 1 over the square root of 1 plus 2x. And some of you may be confused how I get that. So that's the definition of a half power square root, and negative means putting it in the denominator. All right. So let's, how about this? I'll write it out here. So I want f prime of 4, right? So let's plug in 4. 2 times 4 is 8. 8 plus 1 is 9. Square root of 9 is 3. So 1/3 is f prime 4. I guess the whole thing with it. And then I get x minus 4. I don't know what's going on here. Gosh, so remember I get 1/3. So I get 3 plus 1/3 parentheses x minus 4. So now I have an equation that's my linear approximation. Okay, I got my numbers. I fill in this one, and I have x minus 4. So I want to approximate 3.9. So it's going to be, let me type this up, 3 plus 1/3. And it's going to be 3.9 minus 4. So again, you can calculate this in the head. 3.9 minus 4 is negative 0.1, or negative 1/10. And if I multiply this out, I get 3 minus 1 over 30. And, oh, hold on. 1/3 is going to be, 1/3 is going to be, let's find a common denominator first. Minus 1/3, 1/3 will be 10 over 30 times 3 over 30. I kicked this minus out in front. Oh wait, it's multiplication. So it's just 3 minus 1 over 30. Okay? And that's my approximation. I don't need to know if it's underestimate or overestimate, but that's an estimate that you could figure out without having to use a calculator. So you have worksheets that I want you to practice. You're going to watch this or do the worksheet for this in the class. I'll collect that on Monday. I believe I have one more video for you over the weekend, so keep an eye out for that. Enjoy through the weekend. I miss y'all. Can't wait to see y'all. And take care.